So the apparatus we have here is a micro voltmeter, a very sensitive voltmeter that we've connected across a coil of wire. And the voltmeter has got, or can give, both a positive and a negative deflection depending on the direction of the voltage. Now we've got a small magnet here which we're going to move towards the coil. And as we move it towards the coil, the magnetic field strength in the region of the coil will increase. As we withdraw it, the magnetic field strength will decrease. Now as we increase the magnetic field strength by moving it towards the coil, what that will do is it will mean that there is more magnetic flux lines passing through the coil, passing along the axis of the coil there, perpendicular to the plane of the coil. As we increase the number of magnetic flux lines passing through that coil, what we will do is we'll induce a voltage one way, and as we reduce the number of magnetic flux lines passing through the coil, we will induce a voltage in the other direction. If I just leave the magnet though stationary in the coil, so there's no change in the magnetic field strength, then we don't get any voltage at all. And again, you can see moving in and out of the coil, we get a voltage induced in one direction and then in the other direction. Now, the other way we can induce an EMF is, instead of moving a magnetic field relative to a coil, relative to a conductor, what we can do is we can move a conductor here, this straight wire, relative to a magnetic field. So you can see we've got a loop of wire here, basically this blue wire, and what we're going to do is we're going to move it perpendicular to the magnetic field between these two magnets. And there's a uniform field between these magnets. As I move the wire down one way, we induce a voltage, induce an EMF in one direction across the wire, and as we move it back the other way, we'll induce an EMF in the other direction. So you can see that if I leave the wire stationary in the field, we get no voltage, but as I move it up and then move it down, we'll get a voltage induced one way and the other. The faster I move the wire, the bigger the induced EMF will be. The faster I move it through that magnetic field, the bigger the induced EMF will be. Leave it stationary, no induced EMF at all. Move it slowly or slower, we get a small induced EMF. Move it very quickly, we'll get a large induced EMF across the ends of the wire. You can see that there.